Hello everyone and welcome to the class. So today in this particular video I'm going to talk about one more very interesting topic from your physical chemistry, and I'm going to take questions which have been asked from this topic in your IIT JAM exam, right? So in the IIT JAM 2019 exam. So the topic of today's class is going to be solid state chemistry. Now this particular topic is one of the most easiest topic, I would say, from your physical chemistry, because this topic you might have started studying from your class 12 onwards, right? In your bachelor's, in your master's, you might have studied the same topic again and again. So you might be knowing almost everything from here. So there are not that much difficult questions which could be asked from here, right? So I'll be talking about this particular topic today in this video. So let's start with it. So before going into the explanation and before going into the question, let me tell you about this particular topic and the significance of this in your like IIT JAM exam. So there are basically 1 to 2 questions asked from this topic. There are not more questions from here, just 1 or 2 questions from this. Marks weightage revolves around 2 to 3 marks. And the difficulty level, as I told you, that this is not a very difficult topic from your physical chemistry. So that's why your difficulty level also ranges from moderate to difficult. Okay, it won't be that much difficult. It would be like rather easy, I would say. All right, so let's take the first question which have been asked in your IIT JAM 2020 for your 2 marks. The question says, actually it was asked in your IIT JAM 2019. Okay, so it was in IIT JAM 2019 exam for 2 marks. It says that the ratio of nearest neighbor atomic distance in your BCC and FCC cubic crystal with the same unit cell length is. Okay, so that's what they are asking. So basically you should know about BCC and you should know about FCC. Now, if you know the structure of BCC and FCC, let me just show you quickly with the help of a diagram. So if I draw a cube, let's say, okay, if I draw a cube of edge length, let's say if the edge length is a small a, okay. So in BCC, what happens that you have atoms at the corners, okay, you have atoms at all these corners, as well as you have an atom on the body center. So you have an atom at the center of the body. Okay, the edge length I am taking is small a for this. Whereas if I draw for FCC, in the case of FCC again, if I draw a particular cube, so in that case, you have atoms at the corners, you know that. Okay, so at the corners you have atoms over here. Along with that, you have atoms on the face centers. Okay, face centers means, let's say this is the front face. So you have an atom at the center of this. This is the side face. So you have the atom at the center of the top face. So atom at the center of this top face. This is atom at the center of this back face, at this side face and the down face. Okay. So this is what, how the particular like BCC, this is your BCC and this is nothing but FCC. So the length is taken in such a way, like you have to consider that particular length where most of your atoms comes, okay, where most of your atoms like lie. So if you look upon BCC, the length where most of your atoms come is this length that goes from here to the back side. Okay, so if this is A, this is B, this is C. Okay, so AC is called as body diagonal. AC is what? That's body diagonal of a cube. So if a cube has a length of A, like edge length of A, then the body diagonal is actually given by a value that is A root 3. So A root 3 is the value of the body diagonal. Now in this A root 3 you have 4R, right? So you can say that you have 4R. Why 4R? 1 radii of this atom, then the diameter of this atom and the radii of this. So radii plus 2 radii, because diameter is 2 radii, right? So overall 4R is equals to A root 3, or you can say that your R is equals to A root 3 by 4. So that's what will come out as the radii of it. But since in the question it has been asked about the nearest neighbor, so when we talk about nearest neighbor, in that case, basically we calculate the value of 2R. Okay, so 2R will be equal to A root 3 by 2. Now this, whatever I told you, is for BCC. Let's do the same thing for FCC. In FCC, most number of atom comes in under your face diagonal. So if this is a face, so this diagonal will be your face diagonal. Okay, so if this is A, this is B, this is C. So AC is called as here as face diagonal. So face diagonal. Now face diagonal has a value. If the edge length is small a, all these will be small a, right? So the face diagonal has a value of A root 2. So these values you have to memorize, or basically these are done very simply with the help of Pythagoras theorem. Just by applying Pythagoras theorem, you can do that. But yeah, if you remember the exact values, like the direct values, it is much like it is much like quicker, that you can respond to the question quickly, right? So that's what it is. All right, so AC is A root 2. Now here again you have 4R, because the radii of this atom, diameter of this atom, and radii of this atom. So overall you have 4R again. So you can say that 4R is equals to A root 2. So basically we have to calculate the value of 2R. So 2R will be equal to A root 2 upon 2. Okay. So 2R will be A root 2 upon 2. Now you have to tell the ratio of these two. You have to take the ratio in such a way that you have to put the value of BCC first and then the value of FCC. So I'll just do here on the screen. So like I'll be putting for BCC, okay, 2R for BCC divided by, for FCC I'm taking 2R for FCC. This is going to be how much? For BCC I have this value, right? So it's A root 3 by 2 and divided by, this is A root 2 by 2. Alright. Now here you can cancel out this 2 and 2, and you can also cancel out this A and A. So what value you are getting is root 3 by root 2. Okay, so or you can say that root 3 by 2. Okay, so in simple way, you can say that it's nothing but root 3 by 2. So that's the ratio of the nearest neighbor atomic distance in your body-centered cubic and your face-centered cubic. So the correct answer for this question comes out to be option number 1. Okay, so that's how this has to be done. Now this was asked in your IIT JAM 2019 and it was asked for 1 marks. Okay, let me just correct this. This is just a printing mistake over here. Alright, so let's take the next question now. The second question which was asked from this topic, again this is from IIT JAM 2019 exam, right? And it was asked for 2 marks. Now it says that the first order reflection of X-ray from 2 to 0, okay, it's a Miller indices given to you, plane of a copper crystal is observed at a glancing angle of 22 degrees. Now wavelength of X-ray used is, now they are asking which wavelength X-ray you are using. Now they have said that round off it to 1 decimal place. Okay, so let's try to do it. It's given that for copper it forms FCC crystal with the unit edge length of 361 picometer. All right. So let's try to do this question first of all. In the answer you also have to do in picometer, so you don't have to change the unit of this. But yeah, for this kind of question, wherever the glancing angle is given and wherever you have to convert that into, like wherever you have to find a wavelength, so that's a very basic equation which relates both the things, that is called as Bragg's equation. Okay, so you are given with Bragg's equation. What is this Bragg's equation tells you? It tells you that 2d sine theta is equals to n lambda. What are these terms? So your d is your interplanar distance over here, theta is the glancing angle, lambda is the wavelength which is needed to be calculated in the particular question. And yeah, so let's put the values and let's try to calculate it. So we need to calculate lambda, right? And since n is not given to you, yeah, it's given the order of reflection, so it's given first. Okay, so the values are already given. Let's put them up and let's calculate it. So it will become 2d sine theta is equals to lambda, because I'm just putting n is equals to 1. And the next step, I just have to calculate lambda, so I'll just put the other things. Okay, so the lambda will be how much? That will be 2 into the value of d for the cubic system. Okay, since it is in face-centered cubic system, so for the cubic system, your value of d is nothing but a upon under root h square plus k square plus l square. Okay, where h, k, and l are Miller indices of the plane, which is already given to you, and into sine 22 degrees. Now here you have to apply your calculator. You have to use the calculator provided in the exam and the digital calculator given to you, and you have to use that to solve it further. Okay, you have to just substitute the values and you will get lambda is equals to 2 into value of a is 361. Already it's in picometer, so no need to change it. Under root, this will be 2 square plus 2 square plus 0 square. Okay, into this will be sine 22 degrees. Now you just have to put the values and solve. Okay, the value of sine 22 degrees is, it will come out around 0.374. Okay, so if you put everything, your lambda will be actually equal to this will be like 2 into yeah, it will be 361 divided by under root 2 square is 4 plus 4, so under root 8 basically, and into 0.374. Solve this and the answer will come out to be 95.48 picometer. So that is going to be the correct answer for this. So the final answer for this particular question will be 95.48 picometer. Alright, so it was very simple, just based upon a equation called as Bragg's equation, and rest of the things are already given to you. You just have to substitute, solve using the mathematics. That's it. Okay, so these were two questions which were asked in your JAM 2019 exam. I hope whatever I explained is clear to you guys and you guys understood it well, right? Okay, so let me just conclude all the things. So the level of the questions in this paper, I would say, were easy to moderate. Okay, easy to moderate, because both of them were very simple questions, right? Concepts which were used is, first of all, it was used like the relation between the edge length and okay, so the first one is your relation, okay, relationship between edge length and the radii, okay, and the radii of atom. So with that you can do. So the first concept was this, and the second question was based upon your Bragg's equation. Okay, Bragg's equation. Okay, so some useful tips regarding your solid state chemistry. It's very simple chapter. Okay, it's very simple chapter. I would suggest you to read the concepts properly and solve as many numericals as possible. Okay, so solve numericals from this. Solve numericals and clear up your concepts. Okay. Alright, so that's it from my side. I hope you guys like the video. Thank you so much for watching it, and I'll see you in the next video. Till then, have a great day.